Here we have a combinatorics problem. A spider has one sock and one shoe for each of its 8 legs, so therefore 8 socks and 8 shoes. In how many different orders can the spider put on its socks and shoes, assuming that on each leg the sock must be on before the shoe? And that's pretty obvious. Obviously, you don't put your socks on after you put your shoes on. You put your sock on and then your shoe. And then this is the problem number 16 from the AMC 12 2001 test. So why did I write a 16 factorial like this? Well, the reason for that is because there are 16 items, 8 socks and 8 shoes that we can put on the spider. Therefore, if we disregarded this condition, the sock must be placed on a leg before the shoe. Well, in that case, we can pick any of the 8 socks or 8 shoes or any of the 16 in total items and place it on the spider's leg. Then after that, we take any of the 15 remaining items and place it on a spider's leg. And then we take any of the 14 and place it on one of the legs, 13, 12, 11, all the way to 1. Therefore, if we disregard this condition, the sock must be put on before the shoe, we have 16 factorial different ways we can do that. However, this is not the correct answer, because obviously we cannot just ignore this condition right here. So how do we put this condition into play? Well, again, the spider has 8 legs, and on each leg will be a sock and a shoe. In that case, there's a 1/2 chance that the sock was put on before the shoe. Therefore, there's a 1/2 chance in which the right combination was used on the leg. Therefore, for all 8 of the spider's legs to have the sock on before the shoe, it's the probability of 1/2 to the power of 8. This is the probability that for each of the spider's legs, the sock comes before the shoe. So now we have these two terms, 16 factorial, which is basically all the socks and all the shoes put on the spider's legs in a random order, and then 1/2 to the power of 8, which is the probability that the sock does become the shoe. So technically we have the two conditions, this condition being that each leg has a sock and a shoe, and then this condition being that the sock must be put on before the shoe. And now we just have to multiply these together. There's a large space in between here, but just disregard that. If we multiply these two together, we get 16 factorial divided by 2 to the power of 8 combinations in which the spider can have both a sock and a shoe on each of its 8 legs. And we are done.